Good day. My name is Gerhard Mohr. I'm a lead security architect, and I'll be introducing you to IMAsolve and our Zero Trust architecture. IMAsolve is a managed security services provider. Our services include managed IT security services and performing security assessments. We provide security strategy development and technology mapping. We perform regulatory compliance assessments to the likes of HIPAA, PCI, NIST, CIS, and so on. We provide penetration testing services for internal and external networks and web applications. We plan, design, and test your cybersecurity disaster and business continuity plan. We provide security misconfiguration assessments on both your cloud and on-premises environments. We are a Zero Trust provider and perform Zero Trust framework assessments, planning for Zero Trust readiness, and designing your Zero Trust architecture. Look at the concept of the dark net. The concept of the dark net should not be confused with the dark web, as we are not talking about criminal activity or dodgy transactions and deals. The dark net was designed to enable people to access resources within the dark network without having any concept of what those resources were. In other words, divorcing network access and instead driving an identity-driven model. What this means is that dark networks did not operate on a traditional model you see today, like the normal public internet. Access and identity was something that occurred within the core of the dark network solution, as opposed to user access. Zero Trust is identity-based connectivity, either human to machine or machine to machine. The Zero Trust network secures your remote workforce and on-site workforce, whether it's managed device or if the user brings its own device. It secures your cloud and corporate networks and resources. Zero Trust provides micro-segmentation of applications, servers, and resources, similar to a network segmentation, but on a more granular scale and with much more control. Organizations are forced to invest and maintain multiple security controls, such as VPNs, privileged user access, jump boxes, application proxies for legacy apps, identity providers, and so on, in order to make it as difficult as possible for attackers to attack their resources. As we can see, the user, whether or not using a managed or unmanaged device, could authenticate with these various controls and then gain access to resources such as the SaaS applications or virtual machine in the cloud or on-premises. This approach somewhat worked, however, still provides access to an attacker after the user passed all the security controls. It is complex, and high support contracts had to be put in place in order to manage and maintain these controls. IMAsolve Zero Trust is redefining security architecture. We simplified how users connect and be authorized to access resources regardless of the device the user is using. There is absolutely no direct connection to any resource in the Zero Trust architecture. It's easier to manage and provide control of your resources regardless of the SaaS applications or whether it's cloud infrastructure or on-premises assets. Remote users and local on-prem users would initiate a SPA packet called a single packet authentication request to the Zero Trust architecture controller, and the controller would verify certain attributes configured to allow and or deny access. In this basic scenario, we can observe that there is no direct connectivity between the client and the resource. Two types of control is shown in this example. Either the controller is managed on-prem or by the organization's IT security team or in a cloud environment. Regardless of who connects to the controller or who controls the controller, the solution remains the same. Data never leaves the organization's environment, and it's always kept locally and or internal to the organization's data plane. All data is encrypted inside a secure microtunnel. Application-based segmentation allows applications to not communicate via IP addresses. Again, it does not matter if it's a local application or a cloud application. This effectively prevents lateral movement and enforces least privilege access. Zero Trust architecture is risk aware and performs certain checks and balances to determine the risk value of the client connecting. If found that the device the user is using to connect is considered high risk, it will deny connectivity to any resource. Risk examples can be locations of the users, the operating system used on the user's device, and whether the user's credentials were leaked, and so on. We have streamlined the manageability of securing your application and managing access. Certificates, additional account setups, and IT workflows is not required in our Zero Trust architecture. Our Zero Trust architecture integrates seamlessly with SaaS applications and legacy on-prem applications and services. Now let's take a look at how a client initiates a connection. The endpoint sends a SPA packet to the controller. The controller sends the user to Azure in this setup to be verified using conditional access, multi-factor authentication, Azure Active Directory, and so on, and depending on what you have configured, and then sends the info back to the controller, allowing the user to communicate with the Zero Trust Access network. The controller then verifies access policies, risk, microservices, and then sends a SPA packet to one of the IDACs, which then allows access to either local resources or cloud resources or SaaS applications. Each connection to a resource is unique on its own and cannot be recreated, therefore eliminating replay attacks and lateral movement, as it creates a single session per connection. Application attacks and lateral movement is eliminated in this scenario. You will notice again that there exists no direct communication with any resource or client, and therefore achieving a dark network. I myself discovered during our design phase that other Zero Trust access providers are protecting cloud and on-premises resources only from remote users' perspective. In the NIST 800-207 policy, which describes the Zero Trust framework, it states specifically that Zero Trust needs to be an end-to-end solution in order to achieve full Zero Trust architecture. We discovered in numerous interviews that internal users connecting to internal resources was not protected, and that an internal user would still be a point of compromise to have access to the castle's resources. This simply was not enough or good enough for us. Our design and architecture achieved full Zero Trust architecture in that we could protect both the local resource and local user, inclusive of any remote users and cloud resources. We protected the local network exactly in the same manner as how we protected remote users to local resources and remote users to cloud resources, and then local users to cloud resources. We implemented the Zero Trust framework as described by NIST 800-207 in an end-to-end solution, and providing total Zero Trust architecture to organizations. How our Zero Trust architecture could have prevented attacks in 2021. In the Colonial Pipeline attack, ransomware affected the organization's billing system in May 2021. An organization had to completely shut down its operations. The organization quickly had to pay 75 Bitcoins, which is roughly about $4.4 million. Our Zero Trust architecture would have cloaked the network from attackers, and Colonial Pipeline would not have needed to shut down its operations to contain the ransomware attack. It would have prevented the attackers from finding the valuable operational core system. If we look at the American Family Insurance, the attack, which was credential stuffing that was used, attackers used personal identifiable information to gain access to more personal identifiable information using automated malicious bots. Our Zero Trust architecture grants access only after being verified. In this case, names and addresses would not have been enough to gather more info. Zero Trust would have hidden the resource and not have allowed attackers to use credential stuffing. If we look at the Japanese dating app, unauthorized server access was granted. The unauthorized server access exposed 1.7 million account holders' driver's license details, passports, and insurance card information. Our Zero Trust access prevents access by continuously authenticating identities on the basis of the trust no one concept. Thank you for your time. If you want to learn more and see a proof of concept, you can make contact with me at gmohr@imosolve.com.